Hey guys, so I wanted to make this thing that I got, and it's a theremin. It says Junior Theremin on it, and it's a musical instrument you play without touching. So this kit is Mad Lab Electronic Kits, Forum Vellum EU, Mad Lab Scotland. See if we can get that in there. So I don't have a really good setup, like always with anything I try to do. I don't have the space, the lights, the organization, I just don't know. Okay, so alright, but I wanted to do it now. Like in my mind, I'm like, I'm gonna make it perfect. I'm gonna get like the camera, the zoom camera in the camera. I'm just like, I've wanted to do this for so long. I want to make just projects, so I'll just do the best I can. Okay, so this is the Theremin is it works in two modes: continuous and discrete. 8 notes over a single octave are available. In discrete mode, 2 push buttons, octaves of the notes, left hand marked minus, lowers the octave, right hand raises the octave. That sounds too crazy to be just this little kit when they're talking about octaves. It's incredibly simple. There's like, okay, so let's go through the part list. We got a 1 mega ohm resistor, a 10k ohm resistor, a 100 ohm resistor, 1k, another 1k, another 100 ohm resistor, another 100 ohm resistor, and then 2 capacitors of 10 microfarads, and then 1 IC, the 555, and another IC, a PIC 12F508. I'm not familiar with that one. Everyone knows the most popular IC in the whole world is the 555, the 555 timer IC, the NE, the 555, and with good reason. Okay, not okay. So I'll just show you this little circuit board. You can see it, and then you can go to their website. I think I'm not promoting. I don't really care. I got this off of, it just says madlab.org. I think I got it from the biggest rainforest in the world in South America. I think I got it from that place. Okay, so there's just 2. Okay, so it has two ICs, 2 of the 8 IC, 8-pin DIP dual inline package, which is the dip, dual inline 8 dip. They're the same, and then you have to look for the little notch there, and then the little notch there. So the best thing I do is to put the ICs on and then just like move the pins, like the 1 and the opposite end pins, move them apart, move that one apart, and then move the other one, like the opposite end, to hold them in before you solder it. Oh my, it's tearing up my nails. See, that's why I don't have nails that look good, because I use them as tools. I use my nails as tools. That's not good. But so then you put them on like that, and then I think the soldering iron is getting hot enough. and I just got this solder. I should probably have some thinner. This isn't the thinnest one, but this is just, I don't have flux, and I'm on my bed, so don't tell me. We have plenty of ventilation and stuff. It's all good, but I should have flux to do this, but I'm breathing this stuff in. No, I'm not breathing. I'm holding my breath. I'm not breathing it in. I'm burning incense too. Oh, come on. Wait, is that better with that? See, I just don't have. I'm not gonna complain about it. Just don't have a shop, enough space to have like a lab or some. It's just stuff. Why did that go out? Oh my god. Yeah, it's the ring light has broken. Oh my god. Why did it just stop working? Whatever. Okay, so I got that one in, and then we'll get the other one in. Ring light I got from Amazon or from Best Buy. It's a good ring light, but it broke, and then I was just gonna hardwire the wire into it, which would be better if I just like hardwired the wire into it instead of the little barrel. They call it the barrel connector thing. It's flashing. Come on, like, God, I'm serious. Why can't I just have a regular place? Oh, this is gonna be cool, you guys. I'm serious. We're gonna get it. Why can't this light just work? What is wrong with this thing? There. It's so weird, this light. That's better. I mean, you gotta have some light to see what you're doing. Okay. Okay, those solder joints look alright. We're doing it on your bed, and all it needs to happen is like a rainstorm and the window breaks open. I'm still sitting here soldering stuff. Okay, so resistor R3, R6, and R7 are all the same as 100, and that's brown, black, red. Brown, black, red. Brown, black, green, gold. Brown, black, brown. Okay, those are the brown, black, brown are the 100s. How could we remember that? Like, brown, that brown, black, brown sounds like a bear, and it's 100, so it's 100-acre, was there 100-acre forest or something? 100-acre forest, so the brown bears, the brown, black, brown bears, brown, black, brown bears are 100 acres, so you just remember. Okay, and then that's going to be R3. Okay, R3. And then R4. No. Yeah, well, it's just 3, 1, 2, 3. R3, R6, and R7. 3, 6, and 7 are the 100 ohm resistors. So if you're building this kit, As Mr. Carlson said, you're doing so at your own risk. There's no high voltage here, but if you know my other stuff, I do like high voltage. You're doing so at your own risk. He's just trying to be safe, very safe there, Mr. Carlson. You need some more uploads, Mr. Carlson. Why did they have that one? Is not the same. What happened to the other brown black? Oh, there's the other brown black. See, brown, black, brown. Brown, black, brown is like a bear in the 100-acre forest, and it's 100 ohms. So that's R3, R6, and R7. So we got those in there. They look spiffy. Look spiffy there. Okay, and then we got some other resistors. What? And I don't have a good place for the soldering iron. It's starting to burn the wood. Okay. So this one is brown, black, orange. Brown, black, orange is 10K. How can I remember that? Brown, black, orange, 10K. And that's R2. Brown, black, orange. Orange. Well, the orange is easy. Orange is the 1,000, so it's easy to remember that. The orange is the 1,000. How can you make an association between orange and 1,000? 1,000 oranges in Florida. 1,000 oranges in Florida and Mar-a-Lago will help save the world. Can't you make a bomb out of orange juice? Oh, I should say that. Oh, okay. No. Wait, what was it about orange juice? Something with orange juice you could do. Something. Okay, so then we're down to the couple. See, it's burning. Why don't they? Okay, wait. There, the solder irons there. Okay. Okay, so then we got brown, black. You guys are gonna be like, watch this video, and you're gonna be like, well, we don't want Sadie to work at our electronics place, but they have all this stuff all organized, and you're just doing this stuff, and then you're just trying to figure out and keep track of learning the network analyzer and the monotonicity and the non-latching digital attenuation, all that crap. Okay, so this one is brown, black. Okay, that's the 1K. Why do we get, oh, the orange is the 10K. Red, 1,000. Okay, so, well, I could have just been a little more organized with this. Okay, so there's two of these. These are the R4 and R5. R4 and R5 are the 1Ks. R4 and R5 is the 1Ks. That's so easy to remember. Just like that. Okay, yeah. Okay. Got those in there. We'll get and there's one last resistor. What are you? Brown, black, green. Brown, black, green is the 1,000,000. So we could be like, that's the green for the million. I mean, that's not how it works, but you know, obviously, I'm trying to get some kind of association so I can just like look at it from far away and be like, yep, that's the 1 million. Instead of using, but you should always, who is it? One of the people online was like, well, you just always use it's either Adrian's Digital Basement or the Noel's Retro Lab, where they those guys always measure they say, oh, I always measure the resistor anyway. Well, yeah, I agree with that. You'd always want to just measure the resistor, and then you could find out what it is. Okay, we got all the resistors in there. You got all the resistors in there, so now we just have to solder these guys up, and it worked. They got this. The soldering irons are really nice, but they all have their own personalities. Like they go off. Like the one station I was at, it would go off. The soldering iron would just keep turning off. Like I'm gonna try to work on these the surface mount devices, and it would keep turning off, and then she'd come over and go, oh, well, you just have to keep tinning it or something, or if you stop using it, it'll turn off. Well, I was using it. There's something wrong with it that just keeps turning off. I mean, oh, did I already get them all soldered? Okay. So, oh no, there's one left. There's one. Okay, so there's that one, and there's that one. There's all those soldered. Those are all soldered up on there. Okay, so oh yeah. So cut the lead wires off of there. Cut the wires. And now some of these you can buy like this. And D-Lab was one time he made a video that he's like, well, people complain that you're tearing those up. Those are expensive. Yeah, you can get these that look like this that are like, like $50. But then you can also get these also that are like $6. And they seem to perform the same. I mean, we're not NASA. At NASA, they're going to get the $50 ones. But they do, you can beat them up. So they are... So like D-Lab he was like, well, they're just, $6 off the biggest forest in South America, the rainforest. And it's like, yeah, I agree with that. I agree with that. Okay. Because it's just a tool. Like your nails, it's just a tool that you can use to just cut up stuff. Okay, now what else do we have here? Just one transistor, and it just says, oh, it's regulator. I bet that's what it is. Okay, it's a 78L05, which is probably the 5-volt regulator, and it has a 9-volt thing, so it runs off 5 volts. I was wondering why it had a 9-volt on it, and it says reg on it. Okay, so the voltage regulator. So it would be easier to just take one of the cords you have. We all have all these cords to charge things with, all these charger cords. Well, it would be easier just to cut that off and then power it with that, instead of using the 9-volt and then using the little pin, using the regulator. So yeah, that's they call it reg here too. Okay, well, yeah, of course, that's how they're doing it. And then you just want to make sure you put that in the little special way it's supposed to be. And let's get some more parts on there instead of just that one. Okay, so that's the voltage regulator. And then we've got the 2 capacitors, which are 10 microfarads, which is 10 over, 10 millionths of a farad. A farad, which is, okay, so the -1, it's the longer lead is always the positive one. So the longer lead on the leads and the longer lead is positive. So you just think it's always, to be positive is longer. It's better to be positive. You'll live longer if you're positive. And that's how, see, you'll live longer if you're positive, and that's the positive lead on the lead and the, but don't go by that. Don't make something and then it blows up and then you're like, well, you're in court for burning down the whole subdivision, and they're like, well, I was just, Sadie said on there, you know, it's that's why Mr. Carlson goes, you're doing so at your own risk. All right, yeah. Okay, so you're breathing at your own risk. You're getting up at your own risk. You're living at your own, you're opening your eyes at your own risk. You're stepping out of your bed at your own risk. Okay, now we have the LED lights. The LED lights, I guess they're just for, well, we'll just solder this on. So we have the voltage regulator and then the 2 capacitors. So we'll solder those guys on there. Solder those guys on there first and then cut them. And then I don't have flux, but this does, yeah, this has flux in it. Obviously, most solders do, but it is nice to have it. You know, you get spoiled at work. It's just like at work if you're like a chef or a video editor or something. You have all the cool audio equipment, all the cool chef stuff, and then you come home and you have like these cupboards and a Cuisinart from 1980 and stuff. Well, I mean, you know, maybe, no, it's not all chefs or something. You know, it's like work has all the cool stuff. Work has all the cool electronics, sandblasters and network analyzers and signal generators. All the really cool stuff is at work. So you could just like take your projects and just get there early and just work out. Now I'm sure that's what will probably get me out of this new job, is when I do something like that. I'll say to you, we realize you're coming to work early. Oh, I just want to get a jump on the day. And it says, all the video cameras, it looks like you're posting stuff on Instagram and using our equipment to make stuff. We're going to have to end your assignment, your temp assignment. We're going to have to end it. Well, nice to know you. And I'll just get another job. I try to follow the rules, you know. People steal paper clips. I'm not gonna abuse the. I'm not gonna steal. I'm not gonna. I mean, it would be nice to use their equipment for stuff like well, this thing right here, this Junior Theremin. So it has some sound oscillations and stuff. You know, it would be nice to put. Okay, so it would be nice to put the it on the or on the not the network or the, what is it, the thing that well, they have a really nice thing that has it's just something Agilent, and it's like digital phosphorus thing. Well, I don't know. I'll have to sneak in there and get some more pictures of it and put on Instagram. No, just kidding. Okay. So I did put the C1 on here, and you guys, in the C1 on here it says 0.1K, which would mean 100, and then on here it says 100 nanofarads. So that makes sense that it's probably the same thing, and it's the same thing that looks like that. But that's interesting that there's the two terminologies they can use: 100 nanofarads and then 0.1K, which 0.1K is, everyone would think, well, that's 1/10 of 1,000, which is 100. Okay, now we got the lights, and it looks like they have them going one way, then the other way, then the other way, then the other way, like that. And then I'm guessing the hard line lines up with the, what would that be? The longer one's the positive, so the longer lead is the anode. And then the hard line is to the cathode. And I always remember that by cathode is black, because a cat, it sounds like cat, and a black cat would be negative. So it's a cathode, a black cat, cathode. You just remember that's negative. The cathode is negative because you just picture a black cat on there. But these, they have them, I guess it's just easier to have them going every other way for the circuit, because whatever makes the circuit the most efficient, JLCBP, what are the two ones? JLCP and the PCB way, whatever can make it where they use less trace lines or whatever to get it the most efficient way. That's what they should use the AI for, is to just go ahead and make the circuit boards so nice, right? Okay, so those lights are in there. I'll just solder those lights. For some reason, the LED lights, it always seems like they have leads that would need the flux a little bit better. It seems like, well, these are adhering pretty well, but it seems like the LED lights have that, like, it's almost like it's made out of a different material, or it's like tin or something. I don't know. It's not tin, but it's like it doesn't seem like it's the same material. The leads I'm talking about seem like they're like square, rectangular or something. They seem like sometimes they're not the same. Yeah, see, they're like it's like a square. The LEDs are like a square. They're not the same kind of material. I mean, it's similar material, but I'm onto them. They're doing something different with those. And then I've noticed that those need more. Whereas that's what you would need flux on, but these are doing good. I think that this solder is pretty good, because it both, look, it says the best flux core. You guys look at that. Like, that's hardcore. You got your cottage core, you got your flux core, you got your hardcore, your apple core. Okay, so those are in there. We're running out of parts, you guys. There's not much left. Okay, then so we got that. Then we got the piezoelectric thing here. Now the piezo, it doesn't have a polarity on here, and I don't think that they do have a polarity like a speaker does, or a buzzer, or some things will look like this, but they'll have a positive, and it's like it has a little circuit in there to make it buzz, but this is just the straight up piezoelectric. And so that's where the piezoelectric is like crystals. It's a lattice crystalline structure in that material, all those like gems and stuff. But as some microphones from back in the day like would actually like generate some of their own electricity because they were so sensitive. But they, obviously there's always an amplifier with it, but the piezoelectric ones, and they have the carbon ones. Microphones are like crazy fascinating when you get into. And I'm just using the old HP thing here, and then I think Google and YouTube, since I click the transgender thing, they make my voice extra deep. That's why I'm blaming them for my voice. No, I don't smoke every day and drink. I don't hang out with Gavin Newsom. It's the Google algorithms that had me check transgender, and then it says, well, we don't want to confuse people, so we're gonna emphasize the bass in instead of making it all Instagrammy and nice. They're gonna be like, F you, we're gonna make you sound like a trans. I have enough help. I don't need any help. Okay. All right. So why are these are okay. Okay, I put them in the wrong way. They were nice enough to drill holes to put the wires through. Yeah, these guys in Scotland know what they're doing, because anytime you get one of these projects, they just have you solder the wires right onto it. But the thing is like, why not just drill out the little bit and then have you go ahead and that holds it in. I usually use the zip ties. And then drill a hole and then put the wires through it and then ratchet it down with that. But this is a good idea. I mean, how long does it take to just drill an extra hole? It's easy to drill a hole, then build a pole. Oh, okay, well, it's not so easy. Well, that's very nice when it does work. It is very nice. It's like I'm knitting. I'm like an old lady knitting, doing my knitting here. knitting with wires and electrons. Okay. Oh, that is very nice. So it goes right through, and then you solder on the back. Those people in Scotland, they're sitting there drinking. Who's the guy in Scotland that does this stuff? Big Clive. See, they're over there. Big Clive in it. Okay, wow. This is all together. You just put the ICs in there. And these were not the same, remember? One is the NE555, which is IC1. So that's IC1 right here. Yeah, that's IC1. And those, you always have to like bend the pins in a little bit. You always want to, they're just weird how they go. And sometimes it's like the sockets are just not made by the same people that made the chips. It's kind of probably like a lot of things, like the people that make tires aren't the same people that make cars. So that one, just to verify that is the 508. I'm going to have to look that up. PIC 12F508. I wonder if it's just an IC that they, made for this just to have, or if it's an actual IC, because some of these kits will have an IC. They'll have the regular, like the 7805 or the NE555 or the whatever, or those, they'll have those logic chips, but then sometimes they have their own little, I don't know if I should say proprietary kind of deal. But okay, those, you don't have to be that delicate with these. You don't have to be that delicate. I mean, it's just the 8-pin ones. Those are so, but you just want to make sure. Okay, yeah. Okay, I'm just looking at the soldering. That looks good. That looks good. Did I already solder those on there? Okay. And then there's 2 switches on there. And the switches are those ones that they can only go in one way, basically. I just bent one of the things. They're like it looks like a square if you look at it real fast, but it's not a square, it's a rectangle. And a rectangle and a square are not the same thing. A square will fit in a rectangle. A square will always fit in a rectangle if it's small enough, but a rectangle won't fit in the square. And that's the whole idea behind this. So they get you to put the switch in the right way. Because it doesn't have its own little notch or whatever. And then it doesn't matter if you have it, you could put it 180 degrees one way or 180 degrees the other way. You could flip it around. It's the same because it's the switch, not like the IC, of course. We all are aware of that one. We'll solder this one in there. Just get these switches in there and see how this is coming. Okay, so the switches are in there. And okay, so now all that's left is the aerial part, which are these, which they gave you a wire, which you can experiment with and have, like, you could totally go and put all kinds of different stuff on there. So what we have is they gave you a wire like so, and then it calls it an aerial. I'm not even doing a good job showing you guys because I'm so excited about this thing. Okay, so what does it say? Sorry, so carefully. Well, it doesn't even talk about the aerial. I mean, obviously, that's the whole point of the. That's so funny. These kits, you guys always have to be aware of this. These kits will always leave, like, they'll always assume that you know some little thing. They'll always assume that you know they'll always leave some little tiny little detail out all the time on these kits. All the time. It doesn't matter who, if it was built by Elon Musk or whoever is the genius behind it, they'll always leave out some little detail because they assume you're smart enough to know, and you usually just have to be aware that there's always this little thing that you're going to have to figure out for yourself with it. And that's how they always, I don't think they intentionally do that. I think it's because it's made by people that make these things. It's like that's what I would do unintentionally, and then people like, Sadie, you made this kit, and you were just testing me to see how smart I was. I see how you work, and it's like, no, I actually literally just forgot. I just well, then you know that, right? Oh yeah, I know that. Well, okay, it's like one of those things. Okay, so now I got the wires in there. And let's just see how we'll just power it on. We're getting dangerously close to just powering this on. This is coming together really nice. It's so funny to come home from work where you solder and test things and do stuff like this at work, and then you come home and you do the same thing. It's like if you're a gardener, if you're a farmer, and then you got home from being a farmer, and then you went to work on your garden, people would be like, "What's wrong with you?" Well, I just love plants. I just love electronics. I wish I could just do this all the time, live stream electronics, and make stuff, and just answer the comments as I live stream. That would be so cool. But you know how organized I have to be to. Oh, see, that wire fell out. What? See, that's why you need flux for this. That would definitely help. I didn't do a good job. I mean, I just barely touched that. And because it is a wire, you're going to need more solder on that. Is it going to hang in there? Sometimes these wires are made out of different. Okay, there. So got the wires. We got this. I can't believe it just came together this fast. I don't. And now the moment of truth, because we'll see if it works. There's 9-volt battery. Okay, we got some light. Oh my gosh, you guys, it actually. Oh, I gotta turn off NPR for a minute. This is so cool. Unplug my. Okay, got the soldering iron unplugged. If you're. Wow, you guys, it actually. Okay, we're gonna have to show you. You've hung in there this long. This is. If you've hung in there for this long, I can't believe it. Oh, look at that. It works. Okay, we gotta get you to see this really nicely. Let's see if we're seeing. Okay, we'll get you. So you can move the octaves, it says. How do you do that? Oh, wow. They've got it. It's like the Theremin, but digitally. Oh my gosh, that's crazy. Wow, that's really neat. It's a lower sounds. You can mess with the antennas. Oh, I can't believe it, you guys. It worked. Oh, this is so much fun. Oh my gosh. Well, can it do other things? So it's got. Oh, look at that! If you wobble it, so now think about the potential with this, you guys. Hold on. Think about the potential with it. You could put it through filters. You could put it through like those pedals they use for guitars. You could break it up. You could have it mess with these wires and make them shorter or longer. But this says the junior theremin. Junior theremin, so there must be a. Oh my gosh, I'm easily entertained, you guys. I, this has so much potential, though. You could really do. Like, it's also just like a sensor. You could just use this, like, if you had a cat or something, a cat, you could just have it like that in a little box and a cat would get close to it. Or anything else. See, look, that's. Well, you're not supposed to touch it, but I like to touch things. You know how I am. Okay. Well, I can. One of the cool things about mode. Oh, wow, it does get higher octaves. That's what. Don't press the buttons together, just press one of them. I'm easily entertained, you guys. I could play with this for all. But you could also get like a couple of them together. You could also get distortion pedals. You could also put it into some kind of like, what's the thing they all use? Like Billie Eilish used, or what that the the sound the sound editing thing that's really popular. I can't remember the name of it. This program that edits sound. It's I know the letter of the that it starts with is at the end of the alphabet, but I can't. Sounds okay. Okay, you guys. Thank you for watching this. And I do have this other one, which is an Atari synth kit, and this one should be. I think I've shown this before when I was going to make it. Oh, it's still going. You still got. So this is supposed to be really cool. Oh my god! I just want to see. This is how I get in trouble. I'll stay up. I'll want to build this, and I'll stay up, and then I won't get any sleep, and I'll go into work, and I'll be tired, and I'll be grumpy, or I'll just won't care, and I'll be like, oh, all right, Sadie, your assignment's over. This is what happens to me. I get so excited about this stuff. This is so cool. Oh my gosh, I could play with this thing forever. Okay, well, thank you guys for watching. Thank you guys for watching. It's been a long one. I'm not good at editing. We'll just have to figure out how to edit these later.